Okay, we're talking about rational expressions today. A rational expression is anything that can be expressed as a fraction like 7/3 or 5 over x plus 6 or something as complicated as t squared minus 5t plus 6 over 4t squared minus 7. These are all different versions of rational expressions. One important factor to remember about rational expressions is they are a form of division. And one of the things we're not allowed to do is we're not allowed to divide by 0. So whatever would cause a rational expression to have a denominator of 0, that becomes undefined. Let's look at this case. X plus 5 over x minus 7. So this is really the expression x plus 5 divided by x minus 7. What you want to ask yourself is, what would make the denominator x minus 7 equal 0? And I think if you add 7 to both sides, you realize x would have to equal 7. So in this case, x can't equal 7, because that would result in this being undefined, because we can't divide by 0. And if x equals 7, that would be 7 minus 7, which would be 0, and it would cause us to divide by 0, which we're not allowed to do. So in a lot of cases, you're going to see something asking about how do we make sure that the denominator of this rational expression is not undefined, or what would make it undefined. And what you're going to be looking for is what the value here is that would cause a problem. What the denominator value would have to be for the variable to make the whole denominator equal to 0. You're going to also have to do some simplification in this section. And simplification happens around things like this: 8x squared over 24x. And you want to see what are the things here that we can simplify. Well, you can look at this in two different expressions. You can look at this as 8 over 24 times x squared over x. And we can divide some things out. 8/24 simplifies to 1/3 because 8 goes into 8 once, and 8 goes into 24 3 times. X goes into x squared x times. So this is actually x over 3. That's an easy way of doing some of that simplification. In some cases, you might have to factor. Let's look at this case. 5a plus 15, and we're going to divide by 10. Well, initially, you might not see any simplification that can happen here. But if we factor a 5 out of that top expression in the numerator and write this as 5 times a plus 3 over 10, then we can simplify here. And we're left with a plus 3 over 2, because 5 goes into 5 once and 5 goes into 2 twice. Okay, so that's how the simplification. However, I want to prevent you from making this mistake. You may be tempted at times, let's say a plus 10 over 2, to cancel out here and make this a plus 5. You can't do that. These are not equivalent. This is not allowed. Okay, don't do that simplification. It would be a over 2 plus 5, because the a would still have to be divided by 2 somehow, and that's not really simplification at all. So you don't want to do that kind of simplification. That's not allowed. Okay, that's just going to cause confusion. The only time you can simplify something out is when it's being multiplied by the whole thing. See, in our previous case, we had the 5 out here and a plus 3 inside parentheses. We can simplify out here like this, or even if you had you can simplify these two things out. Okay, that's allowed. What you can't do is simplify out something like this. Okay, see how the 2 is not being multiplied by everything, it's being added to the a. That simplification is not allowed. Don't do that. Okay. Lastly, you might have to do more factoring than that. You might have to factor out a trinomial. Let's look at this example. X squared plus 3x plus 2. And we're going to divide that by x squared minus 1. We need to factor both the top, the numerator, and the denominator. The numerator is a trinomial that we can factor out to x plus 1 and x plus 2. Those are the binomials that top trinomial factors out to. The bottom is difference of squares. So it's x plus 1 and x minus 1. Notice I'm just factoring. That's all I'm doing. I'm factoring it in all the ways that we learned before. Remember page 336, where there's a list of all the different factoring we can do? Okay, I'm just using that kind of factoring to do this. I factor out the top, I factor out the bottom. I got this new fraction, this new rational expression. And I notice that I have these two things in common, x plus 1, x plus 1. I can cancel this whole expression out. So this thing simplifies to x plus 2 over x minus 1. And that's the kind of simplification you're going to be doing tonight. Okay? So look for those opportunities to factor and simplify and then cancel out. Be very careful how you're canceling out and simplifying. You don't want to do it incorrectly. If you're not sure, look at page 374. And there are some hints about how to not cancel out incorrectly.